All right, guys, Mr. Lamb here coming to you with my third and I hope final video for today. Seems to be the sound is now working on all these. So if you need to go back and rewatch 8.3 or the 8.2 trig problem, those now have sound with them. This is going to be the longest video of the three. It takes about, I don't know, 25 or 30 minutes to get through all this. But this is about two different theorems. The first one's called the triangle proportionality theorem, or sometimes called the side splitter theorem. All right, this first one's sometimes called side splitter. And then the second one is called the mid-segment theorem. So I want to start first by talking about this side splitter theorem. All right, it says, and it's going to go both ways. The theorem and the converse of the theorem are both true statements. It says if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the segments into proportional lengths. What does that mean? That means if DE is parallel to AC. All right, I have four segments that get made, and I'm going to kind of highlight them here. The first segment that's made is segment DB. All right, it is the left side top. All right, segment AD is the left side bottom. On the right side, top is going to be BE, and then right side bottom is going to be EC. So it kind of makes four segments, and that's what you have to think about. So this theorem says that if that is parallel, then my proportion is actually written exactly like this. It's real easy. So the left side top is segment BD, and I put it over top of the left side bottom, which is AD. And that'll be equal to the other fraction, right side top, BE, and right side bottom, CE. All right, and then I'll be able to cross multiply if I need to. All right, the converse of that is also true. That says, just so you know, a converse just kind of switches your if and then statements. So instead of saying if the lines are parallel, then the sides are proportional, it says if you have proportional sides. So if you have, and you know that BD divided by AD, right? If I were to divide those two, and it is equal to the fraction I get when I do BE divided by CE, right? If those are proportional, they have the same scale factor, then the sides DE would be parallel to AC. So that's a real creative way to try to get parallel lines if I can prove that I have proportionality and I can find that scale factor. All right, let's take a look at some examples. These first few all say find x. So we're trying to find the value of x. So let's pick a color and all right, I see that I have two parallel lines. Now, if you need to, what you'll want to do is you'll want to actually turn your screen or turn your page so that your parallel lines run this way. All right, so they run side to side. It'll help you identify your left top and left bottom a little bit easier. All right, so if you need to right now, take your screen, turn it just a little bit so that your parallel lines are running side to side for you. And you'll realize that the top of the left side for you is 12, and the bottom of your left side is 14. The top of your right side is 15, and the bottom of your right side is x. And the problem asks us to find x. This means I'm going to cross multiply. Right, what do I mean when I say cross multiply? I just mean this. I'm going to take the top and multiply it with the bottom, then I'll take the bottom and I'll multiply it with the top. So 12 times x is 12x. 14 times 15 is 210. Divide both sides by 12. And 210 divided by 12 is 17.5. So x is going to be 17 and a half. All right, question number 2. Twist your screen or your page just a little bit. You're going to notice your left top is x and left bottom is 18. Your right top is 56 and your right bottom is 21. Now I'm going to cross multiply. I'm going to do 21 times x. It's 21x. And 18 times 56 is 1,008. Divide both sides by 21. And 1,008 divided by 21 is 48. Keep moving on here. Question number 3. Twist your page just a little bit actually here. This one's really close. Left top is x. Left bottom is 36. Right top is not shown. All right, the right bottom is 45. But the right top they do not show us. What they do tell us is the entire right side has to be 55. So I can just do a little segment addition postulate. All right, if the whole thing is 55 and the bottom is 45, that means the top has to be 10, because 10 plus 45 would equal 55. So now I know my right top is 10. Cross multiply, x times 45 is 45x. 36 times 10 is 360. Divide both sides by 45. 360 divided by 45 is 8. All right, number 4. Number 4, got to turn it quite a bit here. Left top is x, left bottom is 7. Right top, I don't know. Right bottom is 6. This is very similar to number 3. They tell me the whole side is 27, and the bottom section is 6. That means the top section has to be 21. So I can put that 21 in for my top section now. All right. Cross multiply, x times 6 is 6x. 21 times 7 is 147. Divide both sides by 6. And 147 divided by 6 is 24 and a half. All right. Number 5 is almost already parallel for you. So setting up my two fractions should be pretty easy. Left top is 30. Left bottom is x plus 7. Right top is 25. Right bottom is 15. All right. So 30 times 15 is 450. And when I do 25 times x plus 7, I have to make sure that I distribute this. So 25 times x is 25x. And 25 times 7 is 175. Subtract 175 on both sides first. So 25x is 275. Then divide by 25 on both sides. And if I do that, I get x to be 11. And this one, the sides are already almost parallel. So as I look at this, my top on the left side is 6, and the bottom is 21. On the right side, the top is x minus 1, and the bottom is 3x plus 1. So I'm going to have to make sure that I distribute. So when I do 6 times 3x plus 1, 6 times 3x is 18x. 6 times 1 is 6. 21 times x is 21x. 21 times negative 1 is negative 21. I'm going to subtract 18x on both sides. I'm going to add 21 to both sides, all at the same time. So 6 plus 21 is 27. 21 minus 18 is 3x. Divide by 3. And I get x to be equal to 9. All right? That is what's called the triangle proportionality theorem, or what's sometimes called the side splitter theorem. All right, the next one I want to take a look at is what's called the triangle mid-segment theorem. All right, in order to know the mid-segment theorem, you need to know what a mid-segment is. And a mid-segment of a triangle is a segment that connects. It's called mid-segment. That's because it connects the midpoints of two sides of a triangle. So if you have midpoints connected by a segment, that segment is called the mid-segment. So an example of that here would be segment DE. I know that D is a midpoint because of the two marks. One is above and one is below. I know that E is a midpoint because as I see BE has a double mark, EC has a double mark. Those markings meaning that they are congruent to one another. Right? So as long as I have that point right in the middle, it is a midpoint. And if I connect two midpoints, I have a mid-segment. Okay, so what is the mid-segment theorem then? And this theorem is very useful for us, actually. Right? And it says that if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side, and it is half as long. So using that diagram above, if DE is a mid-segment of triangle ABC, then DE is parallel to AC, and the distance from D to E is half of AC's distance. All right, another way to think about that, the mid-segment is half as long as the third side. You can also think of it this way. The third side is twice as long as the mid-segment. All right, some people like to think of it that way. So I'm going to write that one down as well. All right, this is kind of like saying the third side AC is equal to twice the mid-segment. So I can think of that either way. That will help you as we do some of these examples. You're going to see that show up a little bit. All right, let's jump into some examples now. Oh, running out of colors to pick. All right, in question 1, it says identify all pairs of parallel segments. So I can see that X is a midpoint. I can see that Y is a midpoint. I can see that W is a midpoint. So I have a whole bunch of mid-segments. So I'm going to start with the first mid-segment. I don't care, right here. WY. WY is parallel to its third side. So if you think about this big triangle, QRS, WY hits side RS and it hits side QS. It does not hit side QR. So WY is parallel to QR. All right, with that being said, we have another mid-segment right here, XY. Mid-segment XY is parallel to its third side, which would be QS. And the last mid-segment that I want to take a look at is XW. And it would be parallel to the third side of the triangle called RS. So that gets my the first part of that mid-segment theorem. All right, taking a look at a second triangle, doing the same stuff. Mid-segment JK is parallel to third side FH. And that's because J is a midpoint and K is a midpoint if you look at the marks. All right, so if I connect midpoint J to midpoint L, so JL is parallel to its third side, GH. And the third one, KL, mid-segment KL, is parallel to third side, GF. And that is the first part to that mid-segment theorem. In order to test the second part, that those mid-segments are half as long as the third side, I'm going to take a look at these next two examples, example 3 and example 4. All right, so example 3 says if L, M, and N are midpoints, that means I have a bunch of mid-segments of the sides of triangle PQR. It says that PR, this whole distance down here, is 46. It says that PQ, this whole distance up here, is 40. And it says that LN, that's a mid-segment, is 17. So if mid-segment LN is 17, then the third side that it's parallel to is QR. And the mid-segment has to be half as long as the third side. So what is 17 half of? 17 is half of 34. And if I do 17 times 2, I would get 34. So that means QR is 34. All right, it also wants me to find LM. So if I look at LM, LM would be parallel to PR. And LM would be half as long as PR. So half of 46 is 23. The next one is MN. MN is going to be parallel to PQ. And it's going to be half as long as PQ. So if PQ is 40, half of 40 is 20. And the last one says find MR. Well, I know this, M is a midpoint. So MR and MQ have to be the same length. And if it's right in the middle of QR, which is 34, half of 34 is 17. So you'll notice the length of those, the lengths of those mid-segments will show up again. All right, as I look at question number 4, it's the exact same stuff. All right, it's new triangles, some new measurements. It says that FG, this mid-segment's length is 9. It says that G, it's 9. It says that GH, that mid-segment's length is 7. Then it says C to D, this whole big distance up here is 24. So the first thing it asked me to find, it asked me to find CE. So CE, the third side, I'm going to find its mid-segment. The mid-segment that is parallel to CE is GH. And remember, the third side has to be twice as long as the mid-segment. So if that mid-segment is 7, then CE has to be 7 times 2, which is 14. Second thing wants me to find DE. Right? DE is going to be parallel to FG, and it'll be twice as long as FG. If FG is 9, 9 times 2 is 18. Right, FH, and this mid segment in here is going to be parallel to CD and half of its length. So half of 24 is 12. And this last little question says, find the perimeter of triangle CDE. Perimeter means add up all around the outside. So if I want to go all the way around CDE, C to D is 24, D to E is 18, and E back to C is 14, so I just have to add those three numbers up. If I take 24 plus 18 plus 14, I should get 56. So the perimeter of that triangle is 56. All right, 2 more problems here. These are typical problems that you see in this this question grouping. All right, it says find the value of x. So they give us a mid-segment as 7x. And I know that the mid-segment is equal to half of the third side. So half of 17x minus 18. Now, instead of distributing the half, because half of 17 is going to be a decimal, what I'm actually going to do is I'm going to double both sides, right? Because when I double the right side, if I want to get rid of the 1/2 and I say multiply it by 2, I would just have 17x minus 18. And when I multiply the left side by 2, 7 times 2 is 14x. All right? I think that is much easier than trying to distribute a 1/2. If you would like to distribute the 1/2, you may. I just don't like it here as well. All right, subtract 17x on both sides. I get negative 3x equals negative 18. Divide by negative 3. Negative 18 divided by negative 3 is 6. And the question says, find the value of x. So I am done. All right, on the second question, now I'm going to start thinking, remember at the beginning of these notes, I said that you can think that the mid segment is half the third side, or the third side is twice as long as the mid segment. So the third side here is 19x minus 36. That will equal twice the mid segment, 6x plus 31. This is kind of how I know I think about it. This is the way Mr. Jaffe does it as well. If you're following along and looking at any of his work, we both kind of are of the same mindset here. It's easier to multiply by 2 than it is to divide odd numbers by 2. So 19x minus 36 equals distribute. 2 times 6x is 12x. 2 times 31 is 62. Subtract 12x. Add 36. 36 plus 62 is 98. And then divide both sides by 7, and x is 14. All right, moving on to the last page, I believe it's just more examples, except now it's not necessarily telling us to find x. Actually, number 7, it wants us to find the distance from D to E. So when I'm done, here I need to find out what is DE. So DE equals what? All right, well, I know this. I know that DE is a mid-segment because it connects 2 midpoints of a triangle. So that means the third side, 11x minus 25, is going to equal 2 times the mid-segment, which is 4x plus 1. Distribute first. 2 times 4x is 8x, and 2 times 1 is 2. Subtract 8x, add 25, divide by 3, and you should get x to equal 9. Problem does not say find x, it says find DE. DE is 4 times the x value plus 1. Since the x value is 9, I'm going to do 4 times 9 plus 1. That is 36 plus 1, which is 37. So DE is 37. All right, question number 8 wants us to find RT. Well, PQ is a mid-segment, so the third side, 23x minus 6, has to equal 2 times the mid-segment, 15x minus 17. Let's distribute 23x minus 6. 2 times 15x is 30x. 2 times 17 is 34. Subtract 23x. Add 34. Divide by 7. And I find out that x is equal to 4. Well, the question says find RT. Well, R to T is 23 times x minus 6. So if you do 23 times 4 and subtract 6, you should get 86. You can get 86 for a distance. All right, question number 9. Says if MN, NO, and MO are mid-segments, find the perimeter. So I have to find them after the perimeter. It means I have to add up all 3 sides. All right, so what do I know? Well, NO is a mid-segment. It is 42. NO is going to be parallel to JK. And JK will be twice as long. So 42 times 2 is 84. All right, what else do I know? I know that MN is a mid-segment. It is 49. MN is going to be parallel to JL. And JL will be twice as long. So 49 times 2 is 98. And my third one, mid-segment MO is going to be parallel to KL. And KL will be twice as long. So 13x minus 10 is going to equal 2. And that mid-segment is 6x minus 1. I'll distribute 13x minus 10. 2 times 6x is 12x minus 2. Subtract 12x on both sides. Add 10 on both sides. Negative 2 plus 10 is 8. Well, with that being said, I have to find KL. In order to find the perimeter, I'm going to need to find KL. So I'm going to take 13 times 8 minus 10. 13 times 8 is 104. 104 minus 10 is 94. So if I want to find the perimeter of this triangle, my 3 sides are 84, 94, and 98. And I have to add those 3 up. Add those 3 numbers together, get 276. 276 for a perimeter. All right, moving on to question 10 and 11. All right, in 10 and 11, things that I have to look for. I am going to be looking for linear pair. Remember, linear pair, two adjacent angles side by side that make up a straight line. They'll add up to 180. I'm going to be looking for corresponding angles. Corresponding angles are congruent. And I'll be looking for triangle sum theorem, meaning that the three angles of any triangle has to add up to 180 degrees. All right, so with that being said, it says find the missing angles. Right, I have to find all these. So I'm just going to start looking first for any linear pairs that I have, and right here is a pair. That's a linear pair. That adds up to 180 degrees. So if I do 180 minus 127, I get 53. So the measure of angle 2 has to be 53. Now they add up to 180 degrees. All right, as I look along this side, I know that angle 1 and angle 2, what I just highlighted in green is a transversal. This is a mid-segment, so it is parallel. So when two parallel lines are cut by a transversal, I have corresponding angles. Angle 1 and angle 2 are corresponding. So angle 1 is also 53 degrees. Okay, so now I'm looking at this big triangle up here, the whole big thing. Right, it has a 59-degree angle, it has a 53-degree angle, and it is looking for angle 3. So 59 and 53. So 180 minus 59 minus 53 for the triangle sum theorem, 68 degrees. That means angle 3 is 68 degrees. Now I'm going to look at this little triangle down here. All right, triangle sum theorem again. If I know two angles of one triangle, they have to add up to 180. So I have a 53 and a 68. 53 and 68 minus 53 minus 68. Take them away from 180. 59 degrees, angle 4. 59 degrees. And number 5, here's another linear pair. So they have to add up to 180. If I do 180 minus 59, I get 121 degrees. So 121 degrees. So using linear pair, corresponding, and triangle sum theorem there. Very similar for this next one, question number 11. And I'm going to find 1 first. I have this linear pair with 118. So if I do 180 minus 118, I get 62. These two lines are parallel of the mid-segment. So angle 1 and angle 5 are corresponding angles. So angle 5 is also 62 degrees. So now in my big triangle right here has 3 angles, 95, 62, and angle 4. So 95 and 62. 95 and 62, 95 and 62. Subtract them, I get 23. Means angle 4 is 23 degrees. Well, angle 4 and angle 2 are corresponding angles. Angle 4 and angle 2 are corresponding angles, which means angle 2 also has to be 23 degrees. And then finally, angle 2 and angle 3 are a linear pair. So I do 180 minus 23 and get 157. 157 degrees. Four more questions, looks like. Thank you guys. Your patience has been great. All right, just keep working hard here. Last four questions. All right, so when I have two parallel lines cut by a transversal, I might have corresponding angles, which they are congruent, where I might have same side interior angles, and those are supplementary. All right, same side are supplementary. So they might have to add up to 180. So as I take a look at question number 12, here are my two parallel lines. Parallel lines cut by a transversal. Here's the transversal. These two angles are corresponding angles. All right, these are corresponding. So corresponding angles are congruent. So I will take 7x plus 4. I'll set it equal to 10x minus 11. Subtract 7x on both sides. Add 11 to both sides. Divide by 3. And I get x to equal 5. Question says, find the value of x. I am done. Question number 13, parallel lines cut by a transversal. These two are same side interior angles. These are same side interior, so they are supplementary. All right, these are same side interiors. That means they are supplementary, which means I will take 5x plus 2. I will add 11x minus 30, and I will set it equal to 180. Combine like terms, 5x and 11x is 16x. 2 minus 30 is negative 28. That equals 180. Add 28 to both sides. That is 208. 16, divide by 16 on both sides, and x is equal to 13. The question says find the value of x. Value of x is 13. Question number 14 and 15, just like 11 and or 12 and 13, the only difference is they're not telling me to find x anymore. All right, here are my two parallel lines cut by this transversal. These are corresponding angles again. Corresponding angles are going to be congruent. So I'm going to do 9x plus 2 has to equal 15x minus 52. Subtract 9x on both sides. 6x, add 52 to both sides is equal to 54. Divide both sides by 6, and 9 is x. Question says, find the measure of angle CBF. So angle CBF, this angle right down here, it is 9x plus 2. So 9 times the x value, which is 9, plus 2, 81 plus 2 is 83 degrees. So the measure of angle CBF, 83 degrees. Question number 14, last one. Parallel lines cut by a transversal. These two angles are same side interiors. That means they are supplementary. So 6x plus 1 plus x plus 4 has to equal 180. Combine like terms, 6x and 1x is 7x, 1 and 4 is 5. Subtract 5 on both sides. Divide by 7 on both sides. 175 divided by 7 is 25. Question does not say find x, it says find the measure of angle RTV. So RTV is right down here. Its value is x. plus 4, so 25 plus 4 is 29 degrees. So that angle is 29 degrees. Hopefully my voice and the sound of this video has helped you out. I apologize for this one being so long, but it's 3 pages and there are a lot of different entities to these two theorems. So I hope this helped you with 8.4. If you have any questions, please don't hesitate to ask, and I hope you enjoy the rest of your Monday. See you guys.